laboratory experiments. This is all instrument. These two probes are the cloud droplet probes, and this black part is an aspirator. So fog is being sucked. Here is the inlet. Fog is being sucked from this inlet. These four pipes coming out from those four angles. This collection chamber just for arrangement, and this is the pump which is sucking the fog through inlet. This was a discussion of observation study. We measured the four microphysical parameters and other parameters which I discussed earlier for 15 foggy days during the December 2008 and January 2009. And data of these meteorological microphysical parameters are shown in the table. Now, out of these 15 days, all days were not really foggy. There were some hazy days also when the derived liquid water content was very less. So we put the threshold at 0.01 gram per meter cube. So the days when the derived liquid water content was below this threshold value, we explored for the analysis, and further on 9 days of data were considered for this analysis. This figure shows the vertical profile of temperature for all days considered for study. Actually, these are not the all days because of the sounding malfunctioning at Lucknow. We were able to get only vertical. We were able to get vertical profile for only 6 days. So during these days, it can be seen that there was a ground level inversion during some days. There was elevated inversion during these days, some days. So because of this ground level inversions, pollutants tend to trap in this lower region of the atmosphere, and because of that, this results in the increase in the black carbon concentration, which is coming out from the biomass or the vehicular emissions, or maybe from the coal-burnt power plant nearby within sampling area. This is the droplet size distribution for all days considered for study. It can be seen that the droplet size distribution is trimodal nature with the modes at around 6 micrometer, 10 micrometer and 24 micrometer, and the number concentration is varying depending upon the meteorological parameters as well as the concentration of black carbon and cloud condensation in the air. Droplet number concentration, it was observed that the droplet number concentration was increasing with the increase in the black carbon concentration with the linear regression coefficient of 0.707. The probable reason for this is that the black carbon can decrease the efficiency of CCN to form droplets of larger size. Black carbon delays the growth of the droplets, and because of this delayed growth, the size of the droplet will decrease, and because of the size of the droplet will decrease, and the number concentration will increase in the available amount of liquid water. Because of that reason, BC tends to increase the droplet number concentration in the fog.
This is an observation or this is a conjecture? Is this a hypothesis that you are throwing out?
This is a theory. It has been was discussed by the NENS at all. It was a modeling study, and this is what we observed.
Data analyzed through a model, but the reason behind it is not known.
These may be the probable results and which we got in our observation.
Okay, but why it happens that way, nobody has known.
Yes, black carbon, because of black carbon heating, it delays the growth of the droplet.
Heating?
Yeah, we see
Where
heating.
is the heating coming?
But
Where is the BC heating coming?
BC is present in the atmosphere, and BC has property of that heating, and because of that heating, there
is something missing before heating. What does BC does?
it absorbs light. Property of that BC, and that is